The cool thing about systems of equations is there are lots and lots of really neat applications that you can use a system of equations to help you solve. So the focus of this worksheet, I need to get adjusted. The focus of this worksheet is going to be problem solving with systems of equations. It's going to be a longer worksheet. There's lots of different examples that we're going to look at, and I'll try to break it down nice and easy for you. Okay, so let's see here. Got to warm up my screen. There we go. All right, so topic one is just basic direct translation. We have talked about direct translation several times at this point, okay? So I'm going to remind you of the definition, even though hopefully at this point you could recite it to me. Direct translation is the process of converting words to math. And like I tell you just about every time, this is a very informal definition, but at the heart, it's really quite true. We're taking sentences and paragraphs and we're pulling out the math from them and we're converting the math to expressions or equations that we can then use to solve problems. Our goal is to assign variables to unknown quantities. Okay, so this first example is just a very basic direct translation problem. Okay, it says, write a system modeling the given conditions. Solve and write the answers in ordered pair. Now, a lot of times with word problems, we don't write the answers in ordered pair. So this one will write the answers in ordered pair, but we'll also kind of talk about what the ordered pair means. Okay, so in this case, we have the difference of two numbers is 2. So we've got the difference between two numbers, it's 2. So we need to go ahead and start thinking assigned variables. So we're going to let x equal the first number, y equal the second number. So that means the first equation in our system, we're taking these two numbers, we're subtracting them, and we're going to get 2. So x minus y equals 2. We're also going to say that x is the larger number and y is the smaller number. And that'll make sense when we look at this next sentence. So the sum of the larger number and 3 times the smaller number is 30. So now we're taking the larger number, which is x. We're going to add it to 3 times the smaller number, which is y. And that sum is going to be 30. Okay, and I really did need the first number, x, to be the larger one because when we take x and we subtract y, we get a positive sum. So that tells me that x has to be bigger than y. Okay, so let's see how we're going to write this. We want to take the sum of the larger number, so x plus. We want to take 3 times the smaller number, so y is the smaller number, so we're going to take x plus 3y, and that has to equal 30. Well, this is now our system. Okay, and we have the power to solve this any way we want. We could solve this by graphing, although I don't encourage you to use graphing so much. I encourage you to kind of check with graphing. So we're going to solve this with either substitution or elimination, and both methods would be really easy here. So I think for this one, I'm going to go ahead and just do the elimination method so we could get some practice. So let's say that we wanted to get rid of our y's. Okay, well, in order to use the substitution method or the elimination method, remember, you're trying to eliminate one variable when you add the two equations. That's why the method has kind of two names. It's either called addition or elimination because you're doing those two things. So if we wanted to get rid of the y here, we would need to find the smallest number that 1 and 3 go into evenly. So the smallest number these two numbers go into evenly would be 3. So that means I need the coefficients on y to be -3 and +3. Okay, because remember, when you do the elimination method, you eliminate one variable by forcing the coefficients to be opposites of each other. So to do that, I'm going to take this first equation and multiply it by -3. So when I do that, I get -3 times x, which is just -3x. I get, ooh, we don't want to multiply by -3 actually. I hope somebody was like screaming in the background that this is not what we want to do. We want to multiply here by just plain old 3. Okay, and you'll see in just a second why. So we want to multiply this by just 3. So 3 times x is 3x. 3 times -y is -3y. And then 3 times 2 is 6. If we had multiplied by -3 here, the y term would have actually been positive, and when we added the two equations, nothing would have canceled out. Okay, now I'm just going to bring down the second equation. It is x plus 3y equals 30. Okay, so when I add the two equations now, I get 4x because 3x plus 1x is 4x. Well, -3y plus 3y is just 0. 0 plus 4x is just 4x. And then 4x equals 36. Okay, now I need to undo the multiplication of, I'm just going to pull this up here so I have more room. I need to undo the multiplication of 4 and x. I undo multiplication with division. So I divide both sides by 4. 4 divided by 4 is 1. 1 times x is x. And then 36 divided by 4 is 9. Now, as far as the ordered pair goes, we now have an ordered pair that has an x coordinate of 9. We still need to find the y coordinate. So we're saying the first and larger number is 9. Let's see what that would give us for the smaller number. So I'm going to plug in 9 into the first equation. You could plug it into either of these equations. I'm just choosing the first. So we're going to say x is 9. From that, we want to subtract y, which would equal 2. Now you can kind of just in your mind see what y has to be, but I'm going to go ahead and solve this equation. I need to start by subtracting 9. I want to get my negative y alone. 9 minus 9 is 0. 0 minus y is negative y. 2 minus 9 is negative 7. But I haven't actually solved for y here. I need to make sure I get a single positive y. So I divide my y by a negative 1. Well, negative y divided by negative 1 is just positive y. And negative 7 divided by negative 1 is 7. So we think the ordered pair is 9, 7. But let's really talk about what this means. That means the numbers are 9 and 7. That's how I would describe the answer, but let's think about that. We decided that the first number was x, and that was going to be the larger number. Well, x is 9, which is definitely larger than y, which is 7, so that's true. We also knew that the two numbers had to have a difference of 2, so 9 minus 7 really is 2. So everything checks out here, and we would just finally say, hey, these numbers are 9 and 7. Okay?